This video is going to go through two examples, one graphing quadratic inequalities and one solving quadratic inequalities. So this first one is going to be on graphing, and I'm going to start with this inequality that's shown here. And if you notice, this particular inequality, the function is written in vertex form. If the function were written in any other form, the steps would be the same, except I would use techniques that are specific to that form to be able to generate the graph in the first place. So for this one, because it's in vertex form, I know some information. I know the vertex. The vertex comes from the h and the k in the equation. And I know it's going to be -2, -3. I also know from this negative that we have a reflection across the x-axis. So it's going to open down. At this point, if I know enough to know the shape of the parent function, I can graph directly from here. If I'm not quite sure and I don't know if there's any stretch or compression, I would need to use a table of values to see what the other points would be. This one doesn't have a vertical stretch or compression. So I'm going to show you how I would graph this. So if I start with a grid, my vertex is going to be on this for sure. So I'm going to go down to -2, -3. And then I also know a couple other things. I'm going to change color here. I know that for the regular parent function, from the vertex, I can go over 1 and then either up or down 1, depending on if we're opening up or down, to get the next 2 points. And I know if I go over 2, I go down 4 to get the next 2 points. So down 1, 2, 3, 4 is about right here. And over here, I'm going to go over 2, again down 4. And I have the basic shape of this parabola. If I take a look at the inequality, it's greater than, which means it's going to be a dashed line, not a solid line. It extends the length of the entire grid that I have here on my paper, which is important. And now I've just got to figure out where I want to shade on the grid. And in order to do this, I'm going to plug in the point 0, 0. I'm going to use a test point to see whether I need to shade inside the parabola or outside the parabola. So when I plug in 0, 0, 0 is the y and 0 is the x. Running out of room here. And when I simplify this, 0 plus 2 is 2, so I have -2 squared minus 3. And I'm checking to see if this is a true statement or a false statement. 2 squared is 4. So I have -4 minus 3. -4 minus 3 is -7. This is a true statement. And if it's true, it means that 0, 0 is a solution. So 0, 0 is going to be shaded. So I'm going to come back over here. 0, 0 is right here. If I shade this part, I've got to shade the whole grid except the inside of the parabola. In this inequality, I am going to solve for x. So the very first thing I'm going to do is solve this and find the roots, just like as if this were an equal sign, and if I wanted to find the solutions to the equation. So first thing I'm going to do is move the 2 to the other side. So I get x squared plus 6x plus 5 is less than 0. From here, I need to go ahead and factor this. And I'm going to think about using Xbox factoring. So I have 5 times 1 up top, and I have 6 at the bottom. I'm looking for two numbers that multiply together to give me 5 and add to give me 6. Now, for those of you who are pretty good with factoring, if the a value here is 1, a little invisible 1, then these two values that we get are going to give us automatically enough information to find our factors here. So our factors are going to be x plus 5 and x plus 1, and I'm looking for where this is less than 0. And if I set this equal to 0, we find x equals -5 and x equals -1. Now the only other thing I need to do is figure out which direction the inequalities go to give my answer. So I'm going to think about what this looks like. If I go back and look at this inequality here, or this inequality here, I know that I have a parabola. So I'm just visualizing this in my head. I have a parabola with zeros at -5, which is somewhere over here, and a 0 at -1, which is somewhere over here. And I know that this opens up. So the parabola looks like this, roughly. I'm looking for where the parabola is less than 0. So if I come look at my parabola, I'm looking for this section here because this is all less than 0. It's below the x-axis, so it's less than 0 for the value of y. And so I know that the part I'm describing is this part right here. So I'm going to write this as an interval with my two roots as the ends of the interval. And I'm going to say that x has to be in between those two values in order for it to be a solution to this inequality. Hannah says, good job.